Welcome to class today. Today we are talking about domain and range of quadratics. So if you remember from yesterday, we were identifying the key features of quadratics, like the vertex and the axis of symmetry and the zeros or solutions. But today we are looking at domain and range. We have already talked about domain and range. So let's go ahead and review. Remember, we have Dr. XY to help us remember that domain is the x values and range is the y values. So on our supplemental aid, Dr. XY helped us remember that. So if we look at this first parabola, remember a U-shaped graph is called a parabola. The domain is our x values. So remember, Dolor the robot helps us remember that if we want to find domain on a graph, we go from left to right. So our leftmost boundary is right about here, but there's an arrow, which means there's not actually a left bound. So remember, we were starting our domain by putting an X in the middle, and we always use less than signs. Since there's not a left boundary, we cross it off. There's no left boundary. And again, on the right side, there's our boundary. There's an arrow again, which means there's no right boundary. So remember, if there's no left and there's no right boundary, that means our domain is all real numbers. All real numbers. That's what this means. So I'm going to go ahead and erase all of this mess. Let's go ahead and look at the domain for this second one. We'll use a different color here. So the domain here, since this is a real world problem, we're looking at height above ground. That's what our y values represent, and our x values represent time. So this one doesn't have arrows because our time cannot be negative, and neither can the height above ground, because we're talking about a launched object. So it's going to stay at ground level or above. So again, domain is from left to right. So let's start by writing x in the middle and our less than signs. So our left boundary is right here. The x value is 0. And our right boundary is at x equals 4. So x values between 0 and 4 is the domain. Let's go ahead and look at the last one. So again, we notice on the left side we have an arrow. So there's no left boundary. And on the right side we have another arrow. So there's no right boundary, which means our domain is all real numbers. So usually the domain of a quadratic function with 2 arrows up or down, usually that's how you're going to see it, and it's always going to be all real numbers. The only time it's not is when it does not have arrows, like this one, for example. I'll erase so we can see what it looked like again. This one does not have arrows because it's a real world problem, and all real numbers doesn't make sense when we're talking about time. But when there's 2 arrows that go up or down, then your domain is all real numbers. Now let's go back and look at the range. So our range is our y values. So remember, range goes from bottom to top. So at the bottom of the graph, this is where I have the arrows. So again, we have arrows going down. So our range is y values. So since there's arrows at the bottom range, that means there's no bottom boundary. And if we go to the top, it's at, I can't even read that, 1, 2, 3, 4, 5, 6. So y is less than or equal to 6. Ooh, I forgot that over here. Sorry. It's been a little while since we've done this. So we have to remember to go back and put the or equal to if it is included. And there's no open circles here, so it's included. Same with our range here. Range on this one. So again, we start with y and less than symbols. The bottom boundary is all the way down here at y equals 0. Basically, Remember, this is a launched object and it's talking about the height above the ground. So the lowest it can be is 0, which is ground level. And the highest it can be is, I believe that says 64 feet. So 64. And again, these are both included. There's no open circles. So we have to add the or equal to here. And then over here on this one, oh goodness. 1. Oh, that's a 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So the bottom boundary is at negative 16. Negative 16, and it's included, so add the extra line. The top boundary, there's not one because there's arrows. So no top boundary. So I'm going to rewrite this. Y is greater than or equal to negative 16. Don't forget to rewrite it. You never keep it backwards like this. You always rewrite. So the range is going to either be typically, so here is a different situation because it's a real world example, but typically it's either going to be y is greater than or y is less than. You're usually only going to have one boundary because usually there's two arrows going one direction. Or equal to. It's going to be or equal to. I'll add a number there. So y is greater than or equal to a number, or y is less than or equal to a number is what you're usually going to have. So let's go ahead and look at some examples. So example 1, the domain. I'm going to go ahead and set up my domain for all of these. X and less thans. We should be good at this by now. So my domain is from left to right. So here is an example where we don't have two arrows, but this is my leftmost point at negative 2. Notice it's an open circle, so it's not included. So I'm going to leave it just as less than. And then my right boundary has an arrow, so it's going to continue. That means there's no right boundary. So I'm going to rewrite that as x is greater than negative 2. That is the domain. My domain on the other one, there's an arrow on both boundaries, so that means it's all real numbers. Anytime there's neither boundary, you can cross off the inequalities and just write all real numbers. And the last one, your domain from left to right, this is a negative 7, it looks like. So that lowest value is negative 7. It's an open circle, so I leave this as a less than. And on the right side, I have an arrow, so there's no right boundary. So again, I'm going to rewrite it as x is greater than negative 7. When you rewrite it, when you flip these from left to right, then you also have to flip the sign. And let's go back and talk about our range. So the range is from bottom to top. So the lowest value is negative 2. Oh, I forgot to set it up here. So negative 2, and it is the parabola goes all the way down to negative 2. There's not an open circle, so I need to add the or equal to. And then be careful here because there is this point right here. But at that point, when this stops on this side, it keeps going up over here. So that means there's not a boundary, a top boundary, because this side keeps going up. So there's no top boundary, and I'm going to rewrite it as y is greater than or equal to negative 2. So it's okay if both arrows don't keep going up. If one goes up, then there's no boundary. All right, range for this one. So again, there's no bottom boundary. So it's just going to be y is less than, because there's nothing over here. Y is less than, and this right here is at negative 1. Y is less than or equal to negative 1. Over here, my bottom boundary has an arrow that keeps going, so there's no bottom boundary. So y is less than or equal to 1, 2, 3, 4. The max is at 4. So notice your range also has to do with your vertex. So once you find that vertex or the max or min, that's also going to be where your range is. All right, so here are some practice problems that I want you guys to try on your own. So go ahead and pause the video, try these on your own, and then come back and check your answers. So number 1, what is the domain and range of this function? So instead of trying to figure this out, what you're going to do is graph this. Notice a is negative. So this is going to be a function that looks like this, concave down, because a is negative. So graph it and then find your domain and range. You should notice that the domain, since you have 2 arrows, is going to be all real numbers. All real numbers. Or again, we can write that as an R with a double back. And your range is going to be Y values that are less than or equal to a specific number, whatever number the max is. I'm going to let y'all find that out. What's the domain and range? This one has a positive A value, so it's going to be concave up. Again, there's 2 arrows, so your domain is going to be all real numbers. Your range this time is going to be Y values greater than or equal to whatever the minimum value is. This table shows some ordered pairs that belong to this quadratic function g. What is the range of g? So what I want you to do is go ahead and graph these points, plot these points, and that way you would get your parabola and see what the range is going to be. See which one of these is a minimum value. All right? You should notice, so remember, the minimum is the same as the vertex, which is in the center. So if you look right here, the numbers on each side, the Y values, are going to be the same. So we have a 0, 0, 3, 3, 8. Then this side's going to be 8 over here. That tells you that this is the center point. So what you need to know now, or I guess you don't need to know because -1 is the only number over here. So all real numbers greater than or equal to. So that tells you that it's a parabola that looks like this. But again, once you graph it, you should see that it looks like this. It's just going to be the points, but you'll be able to see which one is in the middle. What is the range of this function? So it's already graphed for us. The range is all Y values greater than or equal to -1. What is the domain of this function? So this one is discrete, or it's not discrete, it's continuous, but it is very specific and exact. So the left value is 0 and the right value is about 4.5. So x values between 0 and 4.5. There are ends on both sides. Remember, if it only has one side, that means there's an arrow on one of the ends. And in this case, we don't have any arrows. Last 2 questions. Which statement about the function is true? So first of all, just from looking at this equation, we know that it's concave down. It looks like this. So the range is not going to be all real numbers. The range is never going to be all real numbers. The domain is all real numbers because there's arrows on both sides. The range is the set of all real numbers less than. It's never just going to be less than. It's going to be less than or equal to. And the domain we already said is all real numbers. And then number 7, the table shows some ordered pairs that belong to a quadratic function f. What is the range of f? So again, go ahead and plug this into Desmos, plug each point into Desmos, and then I want y'all to graph it and tell me what the range is. It's either going to be y is greater than or equal to, or y is less than or equal to, and I want to know what that number is. Again, it's going to be wherever the vertex is. So I want y'all to figure out what that number is.